In this video, we're going over the vectors practice test. So first things first, make sure you got your formula sheet. It should look something like this. You got the test itself and you've got your calculator. Make sure your calculator is set to degrees because vectors questions tend to be in degrees. Okay, first thing we got is a dot product. So we want OA dotted with OB. Way you do a dot product is you times each component. So the x's 2 times 0, you get minus 1 times 5, and you've got 4 times 3. That just ends up giving you minus 5 plus 12, so it is 7. The cross product is a little bit more involved. So with the cross product, I guess the formal notation way to write it down is to write I, j, k. You put your two vectors, so 2, minus 1, and 4. That's the first vector. 0, 5, and 3. Make sure you do them in the correct order because it does matter. And then you take each sort of like subdeterminant. So I get I, and then I get rid of all the bits that were under I, those two numbers, and I'm just left with 4 numbers in the bottom right. So that is minus 1, 4, 5, 3. Next bit is minus j. Don't forget about that minus sign in the cross product. It's a bit tricky. Get rid of the numbers under j. You're left with 2, 4, 0, 3. Plus k. And with k, we're left with 2, minus 1, 0, 5. So to do the little subdeterminants, you just times the diagonals. So that's minus 1 times 3, take away 4 times 5. And same sort of process for these other ones. And with I, j, and k, make sure they are underlined. So plus k, and then that's going to be 2 lots of 5, take 0 lots of minus 1. So that's I lots of minus 3, take 20. It's j lots of 6, and then it's k lots of 10. And if we write that back as just a normal sort of vector, that's minus 23 was the I bit. You're going to have minus 6, and then you're going to have 10. So you can write that as a vertical vector or a horizontal vector with square brackets if you want. Next, calculate AB. So AB is going to be, let's see, how do I get from A to B? Well, it's essentially AO plus OB. So it's the negative bits of A. So it's minus 2, 4, minus 1. And then it's just the normal coordinates of B. Oh, I got this wrong way around. Minus 2, positive 1, minus 4. And then it's the coordinates of B. So 0, 5, 3. And then you can just add them. So you're going to have minus 2, 6, and minus 1. Okay, so that's sort of the long, I guess, formal way to do it. But people are probably more used to getting this just between 2 points. So how do I get from A to B? I would have to take 2 with the x's. To get the y's along, I would have to add 6. And then to get the z's, I'd have to take 1. So that's where those numbers come from. Calculate the angle between OA and OB. So essentially, we can just say let theta be the angle between OA and OB. Just notation wise, you've just got to be careful there. And then theta is going to be, well, cos of theta is going to be OA dotted with OB over the mod of each of those vectors. Now in exams and tests, just have a look. We have already got OA dot OB, so you want to look to like earlier parts and just be sure that you're using those if they're relevant. So we have got that at 7. We haven't got the mods, so if we want mod OA, let's do that as a little example, mod OA. It's going to be the square root of 2, minus 1, and 4, all squared. So 2 squared, minus 1 squared, and 4 squared. So that would end up being the square root of 21. And similarly, OB, if we want to work that out, you should eventually be able to do mods in your head pretty quickly once you get used to them. It's 25 plus 9, so that's going to be a root of 34. So those are the 2 bits which go on the bottom of that. Wonderful stuff. Alright, so that is just going to be cos of theta equals all that. So theta is inverse cos of all that. 7 root 21 root 34. And then we can just chuck that into a calculator. So theta roughly equals, so we're going to go inverse cos of, you can hit the fraction button there, 7 on the top, and root of 21 times root of 34 on the bottom. Okay, so 74.8 degrees. And we use 3 significant figures for tests and exams. So 74.8, that's all 3. Okay, next up we've got this figure here. And we'd like to find all this stuff. So find vector expressions for AB. How do I get from A to B? Well, first of all, we want to think about vectors we know. So OA is A, that's that vector there, and OB is B. So those are vectors we're allowed to use. So I might go from A to O and O to B. A to O is just minus A, and O to B is positive B. So that's AB. Next we need OQ. So how do I get from O to Q? Well, it's going to be O to B, and then it's going to be B to P, and then it's going to be P to Q. So O to B is pretty straightforward. I'll just leave it as the capital letters for now. And we need to think about B to P. So BP is parallel to OA and half of its length. So this is half OA. That's what BP is. And then PQ is parallel to BA and a quarter of its length. So this is a quarter of BA. Okay, now we can put in our lowercase letters. So O to B is little b. O to A was little a, so we get half A. BA we don't have, but we do have AB. So BA would have to be minus AB, which is going to be minus A plus B. And I might just write that in, expanding it, but you're essentially going to get A take B, like that. So this is plus a quarter of A take B. Okay. Good. All right, so let's see if we can expand this out and deal with that. So this is going to be B plus half A plus a quarter A, take a quarter B. So if we collect like terms, you're going to get half A and a quarter A, so you get 3/4 of A, and you're going to get a whole B, take a quarter of B. So you're going to get 3/4 of B. Wonderful, so that was OQ, and we've done that. Prove that AB is perpendicular to OQ. So to prove two things perpendicular, you generally want to dot product them, so AB dotted with OQ. So that's going to be minus A plus B, and then we're going to dot that with OQ, so that's 3/4 A plus 3/4 B. Now, absolutely, we can dot all the vectors in with the 3/4 there, but what's going to be a bit nicer is if I take out the 3/4 from the front, so minus A plus B, dotted with positive A plus B, and that just is a property of dot products that you can use. So you get 3/4 there, and now we're going to be foiling it out. So you're going to get minus A dotted with A, you're going to get minus A dotted with B, you're then going to get B dotted with A, and then B dotted with B. All right, now immediately some things cancel out. So the middle two terms cancel out, so that is just the fact that dot products don't matter what order you do them. Be careful because cross products do matter what order you do them. So I'm going to be left with minus. Now A dot A is mod A squared, and B dot B is mod B squared. Okay, so I might just say as A dot B equals B dot A, and any vector B dot V equals mod V squared. Just something like that to show you, you know, I might even go V dot W and W dot V. So we're showing what properties of the dot product we're using because this is a proof. There we go. Cool. So there we are. So this is 3/4 of 0 as mod A equals mod B. And we know that because the question gave it to us. So where is it? Triangle OAB is equilateral. Since triangle OAB is equilateral. Cool. Wonderful. So this equals 0. Therefore, AB was perpendicular to OQ as required. So we can put a little square to end our proof. Excellent stuff. All right, we've got an archer firing an arrow. There's that. And we're going to calculate the position of the arrow after 2 seconds. So this is literally just going at t equals 2, x, y, z, is, let's see, 4 plus 2 lots of 3. It's 1 plus 2 lots of 2. And then it's 5 plus 2 lots of 3. Which is going to be, let's see, 4 plus 6 is 10, 1 plus 4 is 5, and 5 plus 6 is 11. So the position is 10, 5, 11 after 2 seconds. All right, next we're going to be calculating the speed of the arrow in meters per second. All right, so first up we need a velocity vector. That's just the things with the t, so it's 3, 2, 3. And speed is mod v, the modulus of velocity. So that's 3 squared, 2 squared, and 3 squared, like that, which ends up giving you root 22 meters per second. I'm happy with the exact values, but if you want, you can just get an approximate for that. So S to D on the calculator, 4.69. All right, the target's got an x position of 13. We want to find how long it took. So our position is 4 plus 3t. 1 plus 2t. And the z position is 5 plus 3t. And this is supposed to equal some number, 13 at the top, and then we don't know what the other two numbers are, but we only need the top equation. So 4 plus 3t is 13, so 3t would have to be 9, so t would have to be 3 seconds. And then we want to find this actual position. So to get y, you're going to go 1 plus 2t, which is 1 plus 2 lots of 3, which is 7. And to get z, that's going to be 5 plus 3t, and we sub in the t value we found, so that's 5 plus 3 lots of 3, which is 14. So the position is going to be, let's see, well, we knew the x component was already 13, so it's 13 and 7 and 14. That's where it is. That is the position of the target. So this is also the arrow when t is 3. Just like that. Wonderful stuff. All right. Next question. Find the angle the arrow makes compared to the ground during flight. So there's two ways to do this. You can think of the ground there, and we can think of the velocity vector here. I don't really care too much about the other bits, but it's 3, 2, 3. So 3, 2, 3. There's a velocity vector. And then you can think of it sort of like this. You're trying to find some angle theta there. All right, so if we imagine that angle down the bottom is like the shadow, you can imagine this vector would still be 3 and 3 on x and z, but it would be like 0 on the y. And we need the angle between. So that was that formula we used before. Cos of theta is, let's call this vector w. V dot w over mod v mod w. So what we're going to get is, when we do v dot w, we're going to get 18. And then we do the mods. So the first mod is root 22 and the second mod is root 18. So that is cos of theta there. And we're going to go theta is inverse cos of all that. And we can work out roughly what that is. So we go inverse cos, we hit the fraction button, 18, and then it is root 22, and it is root 18. So we can get an angle there, 25.2. Okay, so that's one method. I'm going to call this the lines method. We can also use a planes method. So if you think about what the ground is, the ground is a plane y equals 0, so all the points with a height of 0. And we've got some velocity vector there, which is 3, 2, 3. And we actually did have an equation for angle between a line and a plane. So the angle here is inverse sine. I'm just going to call this angle phi, and there it is. So it's inverse sine, it's n dot d, and you mod them, and it's mod n mod d. It looks very much like that other formula. So that is the line and the plane. That's how we find the angle between those. Make sure it's on your cheat sheet. So this is inverse sine. Now the normal vector to this plane is actually 0, 1, 0, because it's like 0x plus 1y plus 0z. And the direction vector of this line, I don't really care where the thing starts, but it's 3, 2, 3. So we look at dotting these, you get 2. So like 0 lots of 3, 1 lot of 2, 0 lots of 3. And if you look at doing each modulus, you get root 1 for the normal, and you get root of 22 for the other one. And then, so this is inverse sine of 2 over root 22, and I really hope that gives us the same answer. So 2 on the top, root 22 on the bottom, and yeah, we do. So that's phi there, and so phi roughly equals 25.2. I won't lie, that question's pretty tricky, but there's 2 ways to do it, and you can pick one of your favorite ways, don't do both. Okay, consider the vector p there, find the vector x such that 3x equals p. So therefore x would be a third of p. So that would be 1/3 for the first component, 2 for the next one, and minus 1 for the last one. Done. Hopefully that's a bit nicer after the last question. Find a vector v which has the same direction as p with a length of 10 units. So this vector p is v is going to be 10 lots of p hat. Now p hat is a unit vector. The formula for p hat is 1 over mod p times p. That's how we get a unit vector. And the unit vector has length 1 and it's in the same direction as p. So hopefully it makes sense that scaling that up by 10 gives us what we want. So this is going to be 10 over, and it's going to be a big square root. 1 squared, 6 squared, and 3 squared. So I might just work that out here. That is 46. And then it's 1, 6 minus 3. So this equals, let's see. The first component will be 10 over root 46. The next component will be 60 over root 46. And then the next component will be minus 30 over root 46. Now it's a little bit annoying to check this, but if you actually do check this, 46. I'm going to do it to make a point. You absolutely can check this, and it's a really good idea too. So 60 over root 46. What I'm going to do is calculate the modulus of this thing. And I'm hoping to get 10. Now I haven't done the square root in the formula, so I'll get 100. And then when I square root that answer that I just got, I get 10. So yes, it is what we want. And it's parallel to p. Okay, next we got some properties of cross products. So if we FOIL this out, we're going to get a times 2a plus a times minus b. Gotta be very careful about orders and positives and negatives. So this is 2 lots of a times a. So constants can come out the front of cross products. Plus a times minus b. Now, any vector cross itself is 0. So there it is. So this is a cross with minus b. And I'm probably going to swap the order just to b times a, because I think that's a little bit nicer than having a negative sign. So remember, if you've got cross products, v cross v is 0. And v cross w is minus w cross v. Okay, good. Simplify that one there. So we got to FOIL it in. So the first bit that we're going to get is a dotted with b cross a plus, and then it's b dotted with b cross a. Now this is more of like a geometry thing, but if we think about having this vector a and b, remember what the cross product does. It finds a vector which is perpendicular to the 2 original ones. So if I do, well, that's a cross b. Let's see, a cross b. I'm not sure if that's the right way around with the right hand rule, but that's the idea. It's perpendicular. A dotted with b cross a will be 0 because those 2 vectors are perpendicular. And b dotted with b cross a will be 0. So you get 0. The vector 0, not the number 0. Actually, no, sorry, I lied. The number 0, not the vector 0. Because this is a dot product, we're going to get a scalar out. Cool, so 0. Next, plane equations. So, in general, we want a similar picture like this. So, You've got A, B, and C. You've got A, B, and AC. We'd like to get a normal vector to the plane which contains all those. So A, B, and C are on the plane. We want a normal vector. Hey, look, we can do a cross product. So A, B, and AC. So we need those two vectors. So that is 7. 1 down to -1 is -2. And then 2 down to 0 is -2 again. And then AC, if we work that out, so that's -3 up to 2, that's 5. It's 1 up to 3, so that's 2. And then it's 2 down to -1, so that's -3. You have to be very careful with this because it's super duper easy to make a mistake. All right, now let's see. Next, we need the cross product. So AB cross with AC is going to be, now that's -2 times -3, take away, -2 times 2. And I'm being intentionally a bit quicker, I'm not doing the IJK thing. Middle term is minus, and then it's the outer ones, so it's 7 times -3 take, 5 times -2, and then the next component is going to be 7 times 2 take away -2 times 5. Apologies for going down the page there. Anyway, so that's 6 plus 4, so that would give you 10. Next one is negative, and it's -21 plus 10, so that's negative -11. So that would be 11. And then the last component is 14 plus 10, so that's 24. And that is your normal vector. So the normal vector is AB cross AC, so that's the normal vector to the plane. That's the vector we're looking for there. Usually you would scale down your normal vector, like you'd find a multiple of it, which is nice and clean. I can't scale down this one. 10 and 11 don't have many common factors, apart from 1. All right, so the plane equation, looks like this. 10x plus 11y plus 24z equals some constant d, and then we want to sub in a point. So I'm going to sub in the point b, just because that's got a 0 in it, it might be easier. So 4 minus 1, 0, it doesn't matter which point you sub in. So I'm going to get 10 lots of 4 plus 11 lots of -1 plus 24 lots of 0 should equal d. So that's going to give me 40 take 22 equals d. So d would have to be 18. All right, I lied. 11 times 1 is 11. So d would have to be, let's see, 29. And no matter what point you sub in, you'll get the right answer. You'll get d is 29. So you're going to get 10x plus 11y plus 24z equals 29. Now, watch out, if you had like this equation but everything was doubled, that would still be correct. So if you're self-marking any plane equations, any multiple of the entire equation is equivalent. Next, we got to find the area of a triangle. So here's A, B, and C. We have a formula for the area of a triangle. So it's half, and it's a cross product of the two vectors pointing out from a corner of the triangle. So in our case, that's going to be half AB cross AC. Okay, let's find some of these vectors. So AB is going to be, so -5 up to -2 is 3. 6 down to 4 is -2, and then 9 down to 8 is -1. So that's our AB vector so far. Cool. And then AC is going to be, let's see, AC. So that's -5 to -4, so that's +1 for AC. It's 6 down to 5, so that's -1. And then it is 9 down to 8, so it's -1 again. Okay, and now if we want to work out the cross product, yeah, let's do it all in here. So that's half mod of, now it's -2 times -1, so that is 2, take away 1. Then the middle term has a minus sign in front of it, it's going to be -3, take away -1. And then the last term, you're going to get -3, take -2. Okay, So that's going to give you a half. 1. Minus 3 plus 1 is minus 2. Flip it. 2. And then the last term is minus 1. Beautiful. And then if we mod that vector, so that's 1 squared, 2 squared, and minus 1 squared. So that gives you a half root 6 units squared. And we can get an approximate for that. So if I go half times the square root of 6, we can see what that gives us. It is 1.22. 1.22 units squared. So I'll mark both correct, but if you have some time and you're not sure, put an approximate as well, it can't hurt. Find the parametric equations of the line. So what I'm going to say is let A and B be the position and direction vectors respectively. Okay, so A, you can just pick any of the 2 points. So I'm going to pick away. So that is 2, 3, 1. And then B, we need the vector between the 2 points. So it's AB. So that's going to be 3, minus 2, and 1. So that's how that first bit works. And then the equation of the line is just going to be, well, it's x, y, z equals, essentially it's a plus some lambda value times b. And if we write that in parametric form, it's x equals, so it's the a value, so 2 plus 3 lambda. Y would be 3 take 2 lambda. And then z would be 1 plus lambda, just like that. Now, I'm happy if you use t. I honestly don't mind. And I think using a letter like lambda can make it more confusing than it needs to be. But just be aware I'm going to use lambda for this question, just for consistency with notation and stuff. Okay, find the shortest distance. So to find the shortest distance from a point to a line, basically here's our point P and there's a line L. We would like to find a point R on this line such that you get a right angle there. So R is any point on the line, but we want PR dotted with the direction vector of the line to equal 0. So that would mean that the vector PR is sort of perpendicular to the line. That's what we'd like. So first thing we're going to do is we're going to say let R be a point on the line. So R has these coordinates, 2 plus 3 lambda, 3 take 2 lambda, and 1 plus lambda. Those are the coordinates of R, and they come just from the parametric equations there. P is 5, 4, 3. So P, just for reference, is 5, 4, 3. So therefore, PR is, it's all the coordinates of R take all the coordinates of P. So it's 2 plus 3 lambda take 5. It's 3 take 2 lambda take 4. And it's 1 plus lambda take 3. So that's going to be minus 3 plus 3 lambda. It's going to be 3 take 4. So minus 1 take 2 lambda. And it's going to be minus 2 plus lambda. Wonderful. Okay, that's good. So next vector we want, so that's PR. Next vector we want is B, which is the direction vector of the line. And we defined that before, let B be the direction vector, so that's fine. B is the coefficients of lambda from these equations. So the coefficients of lambda were 3, minus 2, and 1. Okay, so that's B. And so here we want 0 to equal PR dotted with B. So that's going to be 3 times minus 3 plus 3 lambda. Hopefully you can see what I'm doing there. The two vectors sort of times each other. Minus 2 minus 1 take 2 lambda. And 1 minus 2 plus lambda. Wonderful stuff. All right. So we're going to get minus 9 plus 9 lambda plus 2 plus 4 lambda. Take 2 plus lambda. And that should equal 0. And then we can collect our like terms. So that's minus 9 plus 2 take 2. So that's minus 9. It's 9 lambda plus 4 lambda plus lambda. So that's plus, let's see, 14 lambda. Now let's see. Cool. All right. So, well, that's good. Then we're going to get 9 equals 14 lambda. So lambda is 9 over 14. Unfortunately, it's a bit of a nasty lambda value, but that is fine. Now, what we're going to get is the shortest distance. Okay. So, shortest distance is going to be the length of that line PR. So, distance equals mod PR equals mod of. And with PR, we can chuck in the lambda value. So, -3 plus 3 lots of 9/14. It's -1 take 2 lots of 9/14. And it's -2 plus 9/14. And close that mod off. So that's going to be, let's see. So it's -3. Actually, I'm going to show you a really cool strategy. So you can go 9 over 14. And I'm going to hit this right arrow and I'm going to store it in L. So alpha L for lambda. So when I want to work this out, I can just go -3 plus 3 L. I have to do alpha L. -3 plus 3L gives us the number we want, and we might actually get a fraction version of that. So that's -15 over 14 there. Okay. -1 take 2 L. So if we work out what that is, we're going to get -16 over 7. -2 plus L is the last bit. So -2 plus L. All right, so now that we got that, we're just working out this distance. So -19 over 14 squared, for example, there. I'll just type that into the calculator. And through the magic of editing, you don't have to watch me type it in. There we go, 2.87. So that's roughly 2.87 units because we found a distance. Wonderful stuff. All right, moving on. So we're going to classify these lines as 4 of those things. The first thing that I want you to do is, well, convert this L2 to parametric. So we need to use a different letter. We've used T for line 1, so we better use S for line 2. 4 take 2x is S, so therefore 2x is 4 take S. So x would be 4 take S over 2. Then I'd also split apart the fraction and go 2 take half S like that. So that's the x value. So y take 2 over 6 also equals s. So y would be 2 plus 6s when you rearrange it. And then z plus 1 over -2 equals s. So z is -1 take 2s. So the first thing you got to do is check whether these lines are parallel. So b2 is the direction vector of the second line. So that's going to be -1/2, 6, and -2. B1 is the direction vector of the first line. So that's going to be -1, 3, -1. And we check whether those two are multiples of each other. We can see that they are not multiples. They almost are. The first one you have to like halve to get there, but then the second one you have to double. So therefore they are not parallel. So that knocks out 2 of the 4 options. They're not parallel and they must not be coincident there. So we've got to figure out if they're intersecting or skew. So what we want to do is we want to compare our components. So x, that equation we get is -1 take t, so that's the x value over here, should equal 2 take a half s. And then we can do the same for y, so 2 plus 3t should equal, and the y value was 2 plus 6s. And then for z, -2 take t should have equaled, what do we get for z? -1 take 2s. All right, so that's x, y, and z. Next, I want to rearrange these equations so that I can get all the s's and t's in consistent spots. All right, so we'll go s, then t, then constants. So this one's going to rearrange to half s, take t equals, and then the constants move across to the right to be 3. Next one's going to rearrange to minus 6s plus 3t equals 0. And then the last one's going to rearrange to 2s take t equals 1. Now we're going to pick 2 out of 3 of these equations and solve them. Alright, so I'll call these equations 1, 2, and 3. And just looking, I can see that if I do equation 1 take equation 3, I'll get rid of the t, because there's like 1 in front of the t in both, well, minus 1. So what I'm going to get is half s take 2s on the left-hand side, and I'm going to get 3 take 1 on the right-hand side, and the t's will go away. So I get minus 1.5s is 2, and then to get the s value, you can just divide. So I can go 2 over 1.5 and see what I get. And then make it negative. So that's going to be, oh well, negative 4/3. Okay, now we just need to get points. So since I used equation 1 and equation 3, I've got to pick one of those two to find the t value. So I'll go equation 1. Half s take t equals 3. We know what s is, so that's a half of minus 4/3. Take t is 3. We can go 1 over 2 times 4 over 3. If you're not confident doing the fractions by hand, you get 2/3. So you get 2/3 take t is 3. So t is 2/3 take 3. And then we can just see what that is. Minus 7/3. So t is minus 7/3. Now we need to compare the points. So if we look at our 2 points on line 1, we're going to have minus 1 take t. We're going to have 2 plus 3t, and then we're going to have minus 2 take t. And then we want to plug in that value we just found, so 7/3 or minus 7/3. So t is minus 7/3 there. Okay. There we go. So I'm actually going to do that trick again. So I'm going to store my answer in alpha t. So I'm going to go minus, let's see, that first component is going to be minus 1 take alpha t. So that's 4/3 of the first component. My second component is 2 plus 3 alpha t. And this works because I stored what t was in t. So you get minus 5. And I'm going to go minus 2 take alpha t. 1/3. Okay, so that's line 1. And if I go line 2, the components there was 2 take a half s. It was 2 plus 6s, and then it was minus 1 take 2s. And I'm supposed to set s to minus 4/3. So I'm going to take minus 4/3, and I might store that in s. So store in s. This just saves you a bit of time. You don't have to do it. But if I go 2 take a half of s, where was s? There. I should get 2.66666 recurring. And then if we go s to d, that is 8/3. Now this is actually a really good example of noticing when something goes wrong with skew lines. So because I used equation 1 and equation 3, my x's and z's should have matched, and they didn't. So if you ever have that happen, you'll know you made a mistake. The mistake that I made was I lost the minus sign there, so that should be minus 2/3. And then t should have been minus 11/3. That would be the actual value for t. So what I'll do is we'll go through and we'll rework out what that first point was. T shouldn't have been minus 7/3, it should have been minus 11/3. And this is a really good example of if something goes wrong, how you can go back and actually fix it up. Alright, now I won't make you watch me put that into the calculator again, but I've just redone that point with the proper t value there. Okay, next we can keep going with the s value. So 2 plus 6s would be that. So 2 plus 6s. So I get minus 6. And then if I go minus 1, take 2s. So minus 1, take 2s. Alright, I get 5/3. Now you're probably thinking again, like, oh no, have we made another mistake because those 2 points don't match? That's fine. We used equation 1, so the x's should have matched. And we used equation 3, so the y's should have, the z's should have matched. So 5/3 and 5/3. So that's sort of your check in these questions to make sure you've done it right. And then the question is, does the last component match from the one equation you didn't use? We never used equation 2. So we've got to see. No, it doesn't match. So therefore, the lines are skew. Because we tried to find an intersection and it couldn't be done. All right, next we got some plane equations. So this is all about our row operations. We've got to make an augmented matrix out of these three. The first one is 1, 1, minus 1, and 0. That's from the first plane equation. Next is 2, minus 3, 5, 11. And then minus 3, 2, 1, 4. Okay, first thing that I'm going to do, I do ask you to show full working in this. But what you can actually do is just, well, cheese it on your calculator, essentially. You still have to show full working because I've asked for full working in the question, but we can know in advance what the answer is going to be. Minus 3, 2, 1, 4, hit solve, and we're expecting the 0.123. That is what I would expect to get, and hopefully we get it. Okay, the way we do row operations is we're trying to get a triangle of zeros in the bottom left corner. So those bottom 3 in the left, we're trying to get to be 0. Row 2 can go to row 2, take 2, row 1. So that's 1, 1, minus 1, 0 stays the same. 2 take 2 is 0, minus 3 take 2 is minus 5. 5 take minus 2 is 7, and 11 take 2 lots of 0 is 11. Row 3 will have to go to row 3 plus 3 lots of row 1, and that'll get us a 0 there. 2 plus 3 is 5, 1 plus negative 3 is minus 2, 4 plus 3 lots of 0 is 4. Okay, so that's the second step. Next step, we got to go to 0 on the bottom middle. So if you try and do row 3 combined with like a row 1, you'll get rid of that first 0 you got in row 3 and sort of undo your work. You've got to do row 3 combined with row 2. And it looks like I can literally just do row 3 plus row 2. So we'll just fill in the other rows first. 0, minus 5, 7, 11. So that's 0, 0, add those together, you get 5, 7 with minus 2, and 11 and 4 gives you 15. Okay, now we read off from bottom to top. So row 3 would tell us that 5z is 15, so therefore z would be 3. And hey, look, that's good, that matches. If we go back up, row 2 would tell us that minus 5y, actually I'll give myself a bit more room. Row 2 would tell us that minus 5y plus 7z was 11. So that's minus 5y plus 7 lots of 3 is 11. That's minus 5y plus 21 is 11. So minus 5y is minus 10. So y is 2. And that's good. Well, that matches the second bit. And then row 1 would tell us that x plus y take z is 0. And we can just plug in the values we got. So x plus 2 take 3 is 0. So x take 1 is 0. So x is 1. So what you can do is say, therefore, the 3 planes meet in a point, and that point is 1, 2, 3. I'm very creative coming up with these questions. All right. Next, we've got 1, 1, 1, 3. Then we've got 2, 3, 4, 5. Again, very creative. Minus 2, minus 2, minus 2, minus 6. Okay. Now, let's see. We can start doing our row operations, but what we might do first is we might see what's going to happen. 1, 1, 1, 3, 2, 3, 4, 5, and minus 2, minus 2, minus 2, and minus 6. Okay, so solve that. It looks like infinitely many solutions. That's a line. So that's what we're expecting to happen. So we'll keep the first row the same. We can have that row 2 goes to row 2, take 2, row 1. And that's going to give us a 0 there. 3 take 2 is 1. 4 take 2 is 2. 5 take 6 is minus 1. And we can actually have row 3. If you want, you could flip all row 3 back to positive first as like a middle step. I'm just going to go straight ahead and go row 3 plus 2 lots of row 1. So when you get zeros all in the bottom, there's two things that can happen. So this one is when you get 0 over here, you get a line. If that number was not 0, we would have no solution. So therefore, we're going to let z equal t. That's what you do when you get zeros all through the bottom. We go back to row 2, and that reads off y plus 2z is minus 1. So that's y plus 2t is minus 1. So that would tell me y is minus 1 take 2t. And back from row 1, that's x plus y plus z is 3. So that's x plus, we know y was minus 1 take 2t, we know z was t, and that should all equal 3. So that's x take 1 take 2t plus t is 3. So that's x take 1 take t is 3. So that's x is 4 plus t. And you can see that corresponds to what the calculator says. Calculator's using z instead of t, but it sort of matches. So therefore, planes meet in a line, and it looks like this. We can give maybe parametric coordinates, so 4 plus t, y is minus 1 take 2t, and then z is t, for t being in R. That's a little thing when you give equations of lines. Technically here, we should have lambda is in R as well, back there. Okay, let's move on. So explain why PA.PB equals 0. I've given you a little hint here. There's a theorem that says that this is a right angle. As angle APB equals 90 degrees, that tells us that PA.PB is 0. And then this is given from the thing above. P is free to move. Explain why the maximum perpendicular is half the length of the diameter. Okay, so P is free to move between A and B. So basically, max distance has P on the top, essentially. Yeah, so P on the top is the best. That is the radius, which is half of the diameter. So there's a few different things that can happen. You can have like P over here, and then the perpendicular distance would be very short. You could have P over here, and again, the perpendicular distance would be very short. If you have P right up the top, that is the biggest possible distance. Okay, we got this point X, so we got to find the vector X and A. So these are going to be the coordinates of A. So go away. 0, minus 4, and 2. Take away the coordinates of X. So that's 1 plus T. It is take 2T, and then it is 3 take T. So we can simplify that down. So that's minus 1 take T, minus 4 take 2T, and 2 take 3 is minus 1 plus T. Okay. XB, it's the coordinates of B, so that's 6, 8, minus 4. Take the coordinates of X, so that's take 1 plus T, that's 8, take 2T, and that's minus 4, take 3, take T. Again, we can sort of FOIL that out. So this will be 6 take 1, so that's 5 take T, that'll be 8 take 2T, and then that'll be minus 4 take 3, so that's going to be minus 7 plus T. Okay, so XA dotted with XB equals. So we've got to just FOIL everything up. So you've got minus 1 take T with 5 take T. You've got minus 4 take 2T with 8 take 2T. And then you've got minus 1 plus T. And you've got minus 7 plus T. Oh, it's a bit of a pain, but we do literally just have to FOIL it. So what we're going to get is minus 5 plus T, take 5T plus T squared for that first bit. You're going to get minus 4 times 8, so that's minus 32. Plus 8T, take 16T, plus 4T squared. And then we're going to get minus 1 and minus 7, so that's going to give us 7. Take T, take 7T plus T squared. Okay, so let's collect our like terms. So 4T squared, I might underline these with some colors to help. So you got T squared, you got 4T squared, and you've got another T squared. 6T squared. Okay, next up, we've got to deal with our T's. So plus T, take 5T, plus 8T, take 16T, take T, take 7T. Okay, Well, first of all, I can see that the 8t there is going to cancel off with the minus 8t there in total. And we can see that that's minus 21t plus 1t. So that's going to give us take 20t. Now let's think about our constants. So with our constants, you got minus 5, you got minus 32, and you've got 7. So that gives you take 30. Okay. Wonderful. Now, was this to show that question? Yes, it was, and yes, we've got it correct, so that's good. Find the coordinates of all points x such that that is true. So if angle AXB is 90 degrees, then we need 0 equals XA dot XB. So therefore 0 is that quadratic that we just saw. So 6t squared take 20t plus 30. So from C is worth mentioning that you know that from C. So 0, well, t equals. Now we can go on to polysolve. So this is still an equation mode on the calculator. All the way back out to the main menu, F2 for polysolve. It's a degree 2 because it's a quadratic. 6 minus 20, 30, solve, and no real roots. So what's going on there? It's because I didn't type minus 30. That's exactly why. Let's try that again. There we go, solve. There we go, that's a lot nicer. So we get 4.456. They're asking for 4 decimal places. So 3 decimal places. 4, 5, 6, or t approximately equals minus 1.122. Cool, so those are the 2 t values, but they want the coordinates of x. So x is this point here. So x, I'll just write it out again. So it's 1 plus t, 2t, and then it's 3 take t. Now, t is 5 plus root 70 over 3. So I'm just going to quickly go up here and try and remember that. 5, we want to use the full version. So 5 plus root 70 over 3. And then maybe rather than giving these approximates, I might just give t equals 5 plus or minus root 70 over 3, just so we can remember that. So I'm going to hit enter. And what I'm going to do is store that in alpha t. Okay, so we're going to get 1 plus alpha t. There it is, and we can convert that to 3 decimal places. So for t is 5 plus root 70 over 3, we have this coordinates for x, so 5.456. The y value is 2t. Let's try that again, 2t. So you get this, 8.911. And then the z value was 3 take t. So S to D, you're going to get minus 1.456. Now, if t is 5 take root 70 over 3, then we're going to get x being, so we're going to do that same thing. We're just going to store 5 take root 70 over 3 into t. We'll see what happens. Okay, so let's hit enter. Let's store it in t, and we'll work through those exact same calculations. So you got 1 plus alpha t, and then we're going to go there. So minus 0.122. You've got 2 lots of t is S to D minus 2.244. And then you've got 3 take alpha t. So S to D gives you 4.122. Cool, so those are our 2 points there. Great. Show that AB is parallel to the line L1. So do we have coordinates for A and B? I think we did. 0 minus 4, 2. So that was A. And then B was 6, 8 minus 4. AB is going to be 6, 12, was that minus 4? So that's minus 6. And then the direction vector of that line is 1, 2, minus 1. Let's go call that B. Let B be the direction vector of the line. So AB is parallel to B, as AB is literally just 6 times B. Done. Show that AB and L1 are on that plane. So how do we show something's on a plane? We check that it satisfies the plane equations. So 3x take y plus z is 6 is the plane equation. So if we plug in the point A, you're going to get 3 lots of 0 take minus 4 plus 2, which is 6. If we plug in the point B, we're going to get 3 lots of 6 take 8 plus minus 4. So that's 18 take 8 take 4. So that is 6. We want 6. And then if we plug in the L, this is a bit weird, but it is 3 lots of, the x coordinate of the line is 1 plus t. Take the y value, which is 2t. And then plus the z value, which is 3 take t. So this is 3 plus 3t take 2t plus 3 take t, which is 6. Wonderful. So as required. Okay, there we go. So, I'll have to fix that formatting. Is it possible for AQB to be at a right angle? So first of all, let me just write out that line a little bit nicer. So x is 8 plus s, y is 4 plus 2s, and z is minus 14 take s. The plane is 3x take y plus z is 6. Okay, is it possible for AQB to be a right angle? So Q is a point on line 2. We would like AQB to be a right angle. So basically, is it possible for QA dotted with QB to equal 0? So let's try and solve that. 0 equals. So QA, well, Q, first of all, is the point on line 2. So 8 plus s, 4 plus 2s, minus 14 take s. So that's the point Q. I think we have coordinates for A and B. So 0, minus 4, 2. And B was 6, 8, minus 4, like that. So QA and QB. Okay. Let's see. I'm going to make it a little bit easier. I'm actually going to go AQ and BQ, just because that'll give us less negatives to deal with. As we want it to equal 0 anyway. So if, well, anyway, if you dot these two vectors, the two negatives are going to cancel out. You're still going to get 0. Trust me, it'll make the algebra easier. AQ is the vector of all the coordinates of Q. So that's 8 plus s take 0 for the A. 4 plus 2s take minus 4. And 14 take s with a minus in front of the 14 take 2. Apologies for the screen crunch there. So that's 8 plus s. It's 4 plus 2s plus 4. So that's 8 plus 2s. And then it's going to be minus 14, take another 2. So that's a minus 16. Take s. So that's AQ. BQ is going to be all the coordinates of Q, so that's 8 plus s. Take all the coordinates of B, so that's take 6. So s take 6. 4 plus 2s take 8, and it's minus 14 take s take minus 4, like that. So that's 2 plus s, that's minus 4 plus 2s, and that's minus 10 take s. So there we go. That's what we got for the two vectors there. All right, next up. 0 is AQ dot BQ. So I might give myself a bit more room over here. 0 equals. Now we've got to dot these two vectors here. I might just put stars next to them so we don't lose them. We're dotting those two together. So the dot product is 8 plus s and 8 plus 2s. That's the first bit. No, I completely lied there. The x component there is 2 plus s. Next, the y components. So we've got 8 plus 2s. So that's a y component for the first one. And then we've got minus 4 plus 2s. And then we've got minus 16, take s, and minus 10, take s, like that. Now we do actually have to FOIL these out. So this first one is 16, it's 8s, it's 2s, it's s squared, it's minus 32, it's 16s, it's take 8s, and then it's plus 4s squared. This is actually feeling very familiar. I think it's just a coincidence. Kind of feels like that. Yeah, it's not exactly the same. Anyway, we'll keep on. So that's good. And then plus 160 plus 16s plus 10s plus s squared. We can collect our like terms. So with the s squareds, that's going to be 6s squared. With the s terms, so that's going to be 8, 2, so that's 10 so far. It's 16 take 8. I might do this. 8 plus 2 plus 16 take 8. It's then 16 and 10, so plus 16 plus 10. So all the s's we get together are 44, so 44s. And then we've got to think about our constants. So let's deal with our constants now. So the constants are going to be 16 is our first constant, minus 32 is our next constant, and that was plus, don't mind my handwriting, 160. So that's going to be plus 144, just like that. Okay, so we want to solve for that equal to 0. Now, it's saying that it's not possible, so my hunch would be that if we try and solve that quadratic polynomial, so it's a degree 2, we're going to get 6, we're going to get 44, and we're going to get 144. I'm guessing the calculator will say no solutions. Depending what mode you're in, it might just give you imaginary solutions. The point is there's no nice numbers that work for this. So this is no solutions. The easiest way, the quadratic formula is actually on your formula sheet there. We had that thing called the discriminant of the quadratic formula, and it was b squared take 4ac. So it's the bit under the square root, and that told you how many solutions there were. So that's 44 squared take 4 and 6 and 144. So we can work that out. 44 squared, take 4 times 6 times 144. Fix that up. Minus 1520. And then you can say, as discriminant is less than 0, we have no solutions for s. Or you can say like no real solutions for s. Therefore, it is not possible that we have the angle be a right angle, AQB. Probably a few different ways to do that. That is the intuition of how I would do that. But yeah, there we go. And that's the end.